Hello, we are the Mockingjays. Tourism is vital to India's economy, contributing nearly 5% of our country's GDP. But the major concern that undermines this growth is tourist safety. Existing safety systems are fragmented and largely reactive, leaving wide gaps in prevention, such as the reviews of this particular app. So, our problem statement is how we can leverage technology to ensure safer travel experiences through predictive, real time, and privacy focused systems. So, we have come up with a solution: a smart tourist safety monitoring and incident response system powered by AI for risk prediction, blockchain for secure digital IDs, and strong privacy safeguards. With privacy preserving geofencing and anomaly detection, it ensures tourists are both protected and confident while authorities gain real time reliable insights. So we call this as the Smart Sentry. So this is the prototype of our application in mobile view. Here we have the user profile, the safety scores, and the basic dashboard. The digital tourist ID is generated by uploading the KYC documents such as Aadhaar, passport, or even PAN card ID, which is then hashed and stored in a blockchain. So here we have the tour section where you can upload your tour itineraries either using an image or document, which our NLP OCR model will scan and upload the tourist spots. If you do not have an itinerary document, our AI will analyze it and produce an optimal tour route. So here we have the maps section where the user can identify risky or busy zones around him, which will display the safety scores, the risk level, and the coordinates of that particular area. So here we have the SOS button. When the user clicks the SOS emergency alert, concerned authorities will receive the security alert from that particular tourist, which includes the information about the tourist and the location coordinates. So this is the dashboard of the concerned authorities, which contains all the information about the tourist and the surrounding areas. So this map helps us to acknowledge any emergency alert received from the user and further resolve it. This dashboard also contains the information about each police unit and the statistics to analyze and improve the performance of each unit. We have also implemented crowd monitoring through the help of interconnected IoT sensors. So during stampedes or overcrowds, based on the crowd density and flow, our IoT sensors will reroute the traffic through alternate gateways using exit assignment algorithms. This is our baseline AI model, which takes the user profile and the historical crime patterns of the tour spots to predict the safety scores of the tourists. This is the output of the AI model. So we have used crime counts, police availability, and the relevant crimes in that particular tourist spot, along with the user profile such as whether the user is traveling alone, whether he knows the language or not, to predict particular safety score. This is an example output. We also use News API to feed live news to the model to dynamically alter the safety score. And for that, we have used an NLP pipeline which understands the context, relevance, and severity of the input from the News API. So here we have an example output. Next up, we have implemented an AI model to detect anomalies in the itinerary of the user using OCSVM or I4S algorithms. This is an example output. We will further develop this into polyline routes to the destination and train this model on huge volumes of itinerary data. This model runs locally on the device to ensure safety of the user, and hence we send only pings to the server to maintain connectivity. Once the connectivity is lost, we initiate the escalation protocols if the acknowledgement is not answered by the user. If any anomaly is detected by the local AI model, it will immediately send an SOS alert to the server. These are some example outputs of geofencing implemented using NCRB datasets. Here's how the IoT architecture works. The user wears a smart band with sensors like accelerometers, thermistors, and etc. Please continuously check the vitals and motions. If the band detects something unusual, like abnormal vitals or the user entering a risky zone, it will immediately raise an alert. If the user does not respond to that alert, the system automatically will send out an SOS signal. The wearable encrypts all the vital signals and the GPS location using AES encryption, tracking it within 150 bytes of data. This data is then passed along the wearable bands, which all acts like repeaters until it reaches a gateway device. The gateway runs analysis on the movement and vitals, for example, spotting altitude changes or detecting anomalies using the three-axis composite acceleration and the y-axis average. From there, the data is securely logged into a tamper-proof storage server, ensuring the information cannot be altered. First responder server decrypts the data, and based on the insights, rescue teams are immediately dispatched to the user's location. The system also manages exit assignments, as we said earlier. And finally, when we look at the costs, the LoRaWAN setup comes at nothing more than 800, while the gateway device is priced under 2.5K. This makes the entire solution highly affordable, and more importantly, it's not just about cost saving. By ensuring safety and quick emergency response, the system builds trust and confidence, which can directly boost tourism in risky or remote areas. In short, it's a cost effective solution with a strong impact on both safety and economic growth.